The second lesson in this section is arithmetic series. Remembering that an arithmetic sequence is a string of numbers, usually, that have a common difference. A series, denoted by capital S, N, is the sum, adding, of a sequence. So for example, S of N would equal the first term plus second term plus the third term, plus the nth term. So if it were S of 10, we'd know the first 10 terms and we'd add them all together. Thus, an arithmetic series is the sum of all the terms in an arithmetic sequence. And if we put them all together, remember, how do you get term 2? So term 2 is figuring out what term 1 and the common difference is. And term 3 is adding another common difference, so it's term 1 plus 2 common differences, etc., 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 until you get to the general term, and that's that formula we had last day. Now, we're not going to derive these two formulas, but these two formulas can be easily figured out if you have the time. Look, but I'm just going to give them to you right now. So when we do a little algebra with that arithmetic series above, there are two formulas that we get, and they both give you the same answer. But what I want you to notice is they have different parts to it. So they both have n. You have to know the number of terms. They both have divide by 2. They both have T1, but T1s are a little bit different because in the second one you have 2 times T1. What I want you to notice is the first example, we have the value of the last term, and in the second one we don't have the value of the last term, and what we simply did is we substituted this thing in right here, but we won't worry about that. So the basic idea is we need to recognize these formulas, and again, you should be having a summary formula sheet as you go through this unit, and then we're just going to decide based on the information given which one of these two should we use. So it's always a good thing to write down the information given. So let's just go through some examples, and again, it's all about using the right formula and doing the right algebra. So in this first example, I have the first term 19, I have the last term 91, so we're going to use this first formula, and we have 7 terms. So I have T1 is equal to 19, I have T7, the 7th term is 91, and I know that there are 7 terms, and what I want to figure out is what is the sum of that arithmetic sequence. So again, if really what we could do is we could add those all together. And it might not take you as long as using the formula actually, but when you have a longer string it becomes much more cumbersome. So we're going to use our S of 7 formula is equal to n over 2 times T1 plus T2. And again, there are a number of ways to do this. If you want to change 7 over 2 to a decimal, you can go right ahead. But at this point right here, you could literally plug it into your calculator. So I'm going to multiply 7 over 2 times 110, and when you do that, you get 385. And if you simply went ahead and pushed all those buttons on your calculator, then you would get 385 as well. So the sum of these 7 terms is 385. Now looking at 1b, what I want you to notice is we do not know T30. So the last term. So again, first plus last. So we don't know the last term. So in this one right here, what we could do is if we wanted to, we could use our formula from last day and we could find T30. Or we could just use the second formula above, and that's what I'm going to use. So again, what do I know? I know T1 is equal to negative 21. I know n is equal to 30, and I'm not told this, but the common difference is 5.5. So notice in the second formula, you have to know the common difference. So again, it's not difficult to find the common difference. What do I do to go from the first term to the second, or the second to the third, and add 5.5? So now what I can do is I can plug this into my formula, the correct formula, and I'm going to have 30 over 2, which is just 15, and you could write that right down if you want now if you want. 2 times t1 plus n minus 1d, n minus 1 times our common difference. And again, right now, you could get out your calculator. You could punch that in if you had a 2-line display calculator. You could punch it in, and you're welcome to do that. But I'm going to just do a little bit of manipulation. And like if we were doing a BEDMAS problem, and here's the numbers I would get until finally the sum of those first 30 terms is 1,762.5. So the moral of the story is we're going to use two formulas, and we want to make sure we use the right one, and it's very important to write down what I know, and that'll really help you choose the formula, especially when you don't have much experience. So let's look at a few more. Determine the missing information from each of these arithmetic series. So I've actually not written out a string this time. I've given you the information. And in example 2a, I want you to notice we don't have t of 23. We don't have the last term. So we're going to use our second formula. So we want to find s of n, and in this case it's s of 23. And the formula is 23 over 2 times 2 times t1 plus n minus 1 times the common difference. So this is just a little practice, seeing it a little bit differently. And now I'm not going to do all the work I did above. If you want to go ahead and do that, you could, but our calculator would spit out that answer. So that's the total of that one. Now the second one, again, here's this algebra piece where, what do I know? I know d, I know s of n, I know n, and I want to find the first term. So in looking back to our two formulas, if I want to find t1, well, t1 is in both of my formulas. But based on what I know, we're going to use the second one. Because again, we know d. We don't know t1. That's what we want to figure out. We don't know the last term. So it really is the second term. So here's where our algebra turns out to be important. So the first thing we're going to do is we're going to put everything in its place. There's s of 15 is equal to n over 2. 15 over 2 times 2 times t1, we don't know t1, plus n minus 1, well, 15 minus 1 is 14, n minus 1d. So that's what we get. And now we're going to simplify everything we can. So 14 times negative 4 isn't simplified. The first thing I want to do is make my life easy. And if this point right here, if you want to do 15 divided by 2 is 7.5, you could. And here's what we get. So we're going to solve this equation. And remember, I need to isolate t1. I have to get rid of 7.5, I have to get rid of 2, and I have to get rid of negative 56. And again, there's different ways to do it. You could expand out the brackets. But what I'm going to do is I'm going to undo that multiplication first. I'm going to divide both sides by 7.5. And when I divide both sides by 7.5, I get negative 46 is equal to 2 times t1 minus 56. Now this is a grade 8 problem. It's a two-step problem. So the first thing we're going to do is we're going to add 56 to both sides. We're going to get 10, and we're going to divide both sides by 2, and what that tells us is the first term is equal to 5. So again, this unit's great to get started in grade 11. Because the algebraic manipulation, again, you don't have to memorize the formulas. You're always given the formulas. It's a matter of applying them correctly. So here's another algebra question. Again, we want to find the number of terms. We're told the first term, we're told this last term, and we're told the total. And what we want to do is we want to figure out how many terms are in that. So we're going to use our first formula because we have t of 1 and t of n. And we're just going to plug things into the right spot. N over 2 times 5 plus negative 190. And again, it's always a good idea to simplify, so negative 1,480 is equal to n over 2 times negative 185. And given that we want to isolate n, I have to get rid of the 2 and the negative 185, so I can get rid of the 2 by multiplying both sides by 2, and the 2 cancels out, and I'm left with negative 2,960 is equal to n times negative 185, but maybe it's better to write it as 185 times n. That's what you're probably more familiar with. And then how do we isolate n? We undo a multiplication with a division. We end up with n is equal to 16. So what that says, in this sequence that starts at 1 and goes to negative 190, there are 16 terms, and those 16 terms, if you figured all of them out and added them all together, equal negative 1,480. Now, we don't care what the terms are. We don't want to know what the terms are. So other examples that we usually see in these kind of questions are stacking questions or things like that. So here's another typical one. A grocery store stacks a triangular display of soup cans, and I'm going to kind of imagine a little picture. So on the top I have 4 soup cans, then I have more, and again it's triangular, so it's getting bigger and bigger as we go to the base, and I don't know how many there are, but in the very bottom one I know there are 100 soup cans. So that's kind of the picture. Starts 4 at the very top and it goes down to 100. And again, it's implied here that it is arithmetic. And what we want to do is know if there's 17 rows, how many cans are in this display altogether. So in the question, it's saying, well, what's S of 17? And what do I know? Well, I know that the top row, the first row, has 4 cans, and I know the 17th row, T of n, the last row, right? T of n has 100, and I know that there are 17 rows. So again, we look at this information, and basically it's understanding the story, understanding what the words represent. So again, things like there are 4 cans in the top row. There are 100 cans in the bottom row. So top meaning first, bottom meaning last. And how many cans? Well, that's S of n if the display has 17 rows, and that's n. So these are questions that are putting language, and we're to understand how that language connects to this unit, how this language connects to the letters. So here's what the question is asking, S is 17, and given that we have the 4 and the 100, we're simply going to figure that out, and we get 884. Now, you could also use the other formula if you wanted. I don't know why you'd want to, but you could use the other formula if you determined determined D. If you determine the common difference using our formula from last day, determine D, and use the other formula. And if you do that, you're going to get the exact same answer, but it's a lot more work. So again, that's why we want to choose the appropriate formula, write down the information we're given. And then finally, the last example is an example like we did in the last unit, so it's going to be a similar solution. So the sum of the first 9 terms of an arithmetic sequence is 192. We don't know what they are, but we don't know where they start. We just know there are 9 terms, and they add to negative 1, or they add to 162. And the sum of the first 12 terms is 288. So we know it's the exact same series, and we know that the first 9 add to 162, and then the first 12 add to 288. And what we want to figure out is determine the first 5 terms. So in this question right here, it might look like, well, if I could figure out those 3 numbers in between, I could go ahead and do that. Because again, the 10th, 11th, and 12th term are the difference between 288 and 162. So that's a possible solution. But the way I'm going to do it is I'm going to solve with a system. So in solving by a system, again, we have 2 pieces of information. So in our first system, in our first piece of information, we know that S of 9 equals 162. And we know n is equal to 9. Now we don't know anything else. We don't know the common difference. We don't know T1, and we don't know T9. So there's not a lot of information we can write there, other than plug the numbers into one of the formula. So it might not be obvious right now, but here's the formula I'm going to use. I'm going to use the second formula. And in using the second formula, what we end up with is 9 minus 1d, 8d. What we end up with is, we end up with a formula that has 2 unknowns. And when we do that again with our second information, the sum of the first 12, so S12 is equal to 288, and n equals to 12. When we plug that in here, what we get, 2 times T1 plus n minus 1, 11d, what we end up with is 2 equations with 2 unknowns, and they're the same 2 unknowns. Now, if you'd have went up above and use the other formula, the T1 plus Tn, when you do your 2 systems, the T1s would be the same, but the problem is T of 9 and T of 12 are not the same number. So when you try to solve that system, the problem is you have too many things you don't know. That's why I chose this one, because the T1 and the T1 are the same, because it's the same series, and the common difference is the same. And when we go ahead and look at these 2 things, we get, I'm going to simplify this. So what I'm going to do right here, because this doesn't look very nice, so I'm going to multiply, I'm going to divide by 4.5, or I'm going to multiply by this. So I'm going to get rid of the 2 over 9. This 2 cancels this 2, this 9 cancels this 9, and then I have 2 over 9 times 162. And when you do that, you get 36 is equal to 2T1 plus 8D. Now, the second one's a bit easier, because 12 over 2 is simply 6. So the way I could get rid of this 6 is divide both sides by 6. And I could have done that right here. Instead of multiplying by 2 over 9, I could divide it by 9 over 2. And again, your calculator is very useful. And what we end up right here is 2T1 plus 11D. So again, something really nice happens. I have a system of equations. I have 2 equations. I have 2 unknowns. And the simplest way to do this is elimination, because the T1s are the same. 2T1, 2T1, when you subtract, you get 0. And I have to figure out D anyway, right? In order to figure out the first term, I have to figure out T1 to figure out where to start. I have to figure out D to figure out how to get those next numbers that I want. And we have a really simple equation to solve, and we get D is equal to 4. So that's really important. D is equal to 4. I'm going to need that eventually. But one reason D is really important is, now I have D, I can go back to any one of these 2 equations. So I can go back to this original equation, or I could go back to this original equation. And if I plug in my D information, I can figure out T1, which is the starting point. And then using those 2, I can go ahead and solve. So I'm going to use the second one, because the second one, 12 over 2 is 6, and there are no fractions. So what I'm going to do is I'm going to use that information I've just found, and I'm going to substitute it in 11 times 4 for a common difference. And again, what I want you to notice now, there is only one unknown, and I can go ahead and solve. So we're gonna divide both sides by 6. Well, here, let me do everything in order. First thing I'm going to do is simplify. Then I'm going to divide both sides by 6. And when I divide both things by 6, I get 48 is equal to 2t1 plus 44. Then I'm going to subtract 44 from both sides, and then I'm going to divide by 2. And what I end up with is t1 is equal to 1, or t1 is equal to 2. So to answer the actual question that's being asked, determine the first 5 terms, well, my first term is 2, and given that my common difference is 4, there are my first 5 terms.